So Tom wants to buy a phone. He saved $400 per month on 25th of each month in his bank. So starting from Jan 2012, on first day of each month of 2012, he withdraws half of the total amount of money from his bank for food. So that means he withdraws the money on each month of the first day of each month, assuming Tom has $250 is in his bank on 31st December 2011. So the earliest date, so for this kind of question and dealing with recurrence relation, it is quite common, and the first thing we need to do is to write out the cash flow over this period. That means starting from the earliest date, 31st December 2011 is the earliest of all the dates. So it is the beginning, so I just write down December 2011, 31st is $250. Okay, so you want to write down a recurrence relation, means how do you relate when you ask talking about recurrence relation, is always relating this period with the earlier period. I do not know, then I'll just form an expression of UN in terms of the UN minus 1, the previous period. So but I need to know what is my UN first, where UN denotes the amount in his bank account on the last day of the end month after 2011. So after 2011 means 2012, nth month after 2011. So let's say my first month January is 1st of January is on the first day of each month he withdraws half. So on the first day of January 2012, he would have withdrawn half of $250. Therefore, he is left with half of $250, right, after withdrawing half. So what happens on the 25th of that month? So on the 25th of January 2012, he would save $400 into his bank. Therefore, it will be half times 250 plus 400. Okay, so this is, we can spare the dollar sign, okay, just to, okay, so half times 250 plus another $400. So this is my last day of the month, doesn't matter, okay, because from 25th Jan to the last day of January, he's not going to do anything with his money. He's not going to withdraw. He's not going to put in more money. So this could be taken as the amount at the last day of the month as well. So this would be my U1, the first month after 2011, the last day of the first month after 2011. Yes, the last day of the first month after 2011 would be this amount. Then let's say if when you go to 1st February 2012, we will withdraw another half of this amount. So half times 250 plus 400. Okay, you might ask, why don't I just input these figures in the calculator and get a single value? That will make the value nicer, right? But I do not want to do that, because if I do that, then I will not see a pattern. Take note, this is actually a geometric progression question, and we need to see that this is actually geometric progression and be able to use the formula to get this figure out. That would be more useful than using a calculator to calculate the individual value at this individual months. So let's see what happened when we come to the 25th of January, which is essentially our U2. Okay, then at this stage we would just add another, because we just add another. Okay, for this part I would simplify. I will simplify by taking half square, not the whole thing, but just simplifying like this. So plus half times 400 plus another $400. So note that this part from here to here is just this amount. So I'm adding just $400 to it at the 25th of, nope, make a mistake here, should be 25th of February, because at the 25th of each month he credits another $400. Therefore, this is U2. We realize, what do we realize? Okay, we realize from UN every time at the next month, the amount in the next month is equals to half times the amount of the on the last day. The amount on the last day of the next month is always equals to half times the amount on the last day of the previous month, and add another $400. So this is my plus another $400. So this is my UN. Okay, so if this is my UN, so there are a few ways to get this. Okay, one of them is the forward substitution method, the other is the backward substitution method. Alright, how do I do the forward substitution method? Is based on this. Let's say because I know my U1 is this, I could equals to, while U1 equals to half times 250 plus another 400. Okay, then my U2 would be using this recurrence relation. Okay, so this is my answer to the first part. U2 using this recurrence relation, I will take half multiply to this U1. Okay, U1 here, because using this recurrence relation, half time U1 plus $400 is my U2. So U1 I will replace with this one. So it will be half times 250 plus 400. That means I will have half square 250 plus half times 400 plus 400. Okay, so and then the next thing is U3. So I'll write this here, UN equals to half times UN minus 1 plus 400. Okay, this part answer to the part 1 question. So here, then what is my U3? My U3 is just, according to the recurrence relation equation, is equals to half times U2 plus another $400. So this means that my U2 is actually, okay, so what is this? My U2 is just everything here, so it's just half square times 250 plus half multiplied to 400 plus 400 inside of here. So I'm just taking this part and sorting in here. So this would give me half cube times 2 multiplied by 250 plus half square 400 plus half times 400 plus 400. Now do you see a pattern over here? So this part is actually a geometric progression with first term 400 and the number of terms. You see, when it's 3, the number of terms is 3. When it's 2, 1, 2, 3, right? So when it's 2, the number of terms here is 2. And when it is 1, the number of terms here is 1. I'm not talking about the half times 250. I'm not talking about this part yet. I'm not talking about this part yet. So this part is, I'm only talking about the part trailing behind this term. Okay, it's a geometric progression. Okay, but this part is by itself, but there's a pattern to see. So when this is 3, you know that this is 3. The thing here is 3. When this is 2, you see a 2 here. When this is 1, then you see a half to the power of 1. So therefore, I can make using this method, I can see, okay, my UN is equals to, of course, when this is 3, this is 3. So therefore, when this is UN, this would be half times half to the power of n, okay, times multiply by 250, okay, plus the behind would be a geometric progression. Now you know that for a geometric progression, we have this formula where S number of terms, right, equals to A first term 1 minus R times to the power of number of terms over 1 minus r. So number of terms here is based on this. So let's say when this is 3, when we have a 3 here, we have 3 terms over here. When it's 2, we have 2 terms over here. Therefore, when it's n, we know that there must be n terms over here. So that means the number of terms is n. So what is my first term? My first term A is the 400. Okay, in each case of this case here, the A you see is the 400. The 400 is the first term of this entire geometric progression. So therefore, I would just use the formula and write 400. Okay, and this would be 1 minus, what is the common ratio of this geometric progression? Okay, geometric progression has a common ratio between the subsequent term and the previous term. So if I multiply half to 400, I get the next term, half times 400. If I multiply half again to this term, I get half square times 400. And as my u3 goes to u4, you will see that this pattern gets repeated and the terms becomes more and more, and each subsequent term is a half times the previous term. Okay, so therefore my common ratio is half. The point is the common ratio between each term here is half. So therefore I have a here 1 minus half number of terms in this geometric progression would be n. When it comes to un, the number of terms would be n, because when it comes to 3, there's 3 terms over here. But so therefore, let's see, when it goes, then after that 1 minus half the common ratio. Therefore, from here I will simplify to see that I will get to the answer that they want. So let's see. Let's just remove this part to give myself some space. Okay. So we have it here equals to half n multiplied by 250 plus, okay, 1 minus half is half. 400 divided by half is just 400 times 2, so 800. And we have 1 minus half n. Okay, so this one, when we multiply, okay, 800, I will get 800 multiplied by 1, I will get 800. Then 800 multiplied by my minus will be minus 800 half to the power of n. This is 250 multiplied by half n. This is 800 multiplied by half n. So therefore 250 minus, okay, minus 800 would be minus 550 multiplied to half n. Okay, so therefore I have gotten the answer over here. So that is the answer. Okay, so I'm going to get to the other part of the question. I'll just keep this. I'll just skip this. So this equation is will be pretty useful later. Okay, so let's see. So now, given a phone that costs $850, explain why Tom is unable to buy the phone. So in order to buy the phone, to buy the phone, the number of amounts in the account for a certain period of for a certain month must be greater than $850 so that he will be able to buy the phone. So to show that he is unable to buy the phone, then I need to show that UN is smaller than 850. Okay, just now was as long as you have $850, you could buy the phone. So to show that he's unable to buy the phone, the amount of his bank account must be always less than $850. So this is, in other words, we have to show this. We have to prove this. We have not yet proven it. So in other words, we must show that En minus 850 is smaller than 0. How do we show this? So let's get back to what was our UN. Our UN was 800 minus 550.5n. So let's see. 800 minus 550 times 0.5n minus 850. So this would be equals to, so that means UN minus 850 equals to this. Okay, so 800 minus 850 is minus 50 minus 550.5n. Okay, so we know that this is negative of 50 plus 550.5n. But I know that this is always a positive number, because 0.5 to the power of n is a positive number. It will give you a positive number. And I know that n is a positive number because n is the number of months after December 2011. It could not be a negative number, and so this will always be a positive number. Since this will always be a positive number, multiplying to a negative, that means this will always be smaller than 0. Okay, and it could not be 0 because there's a 50 over here, and this is a positive number. So that means negative must be smaller than, this whole thing must be smaller than 0. Since that's the case, my UN minus 850 is smaller. Is smaller than 0 means my UN is smaller than $850. It's always smaller for any n, because we did not state what is the n here. So for any n, for any number of months, the amount of money in the last month will always be less than $850. That is why Tom is unable to buy the phone. So now going to the next part of this question, just make some space. So now they tell us that December, okay, find maximum percentage of total amount of money in the bank that Tom should spend on food every month in order to buy the phone on the last day of December 2012. December 2012 means n equals to 12, correct? Because this is 12 months after 2011. So that means now we want the U12 to be more than 800, more than or equals to $850. But we cannot use the expression that we had just now, because now we are going to find the maximum percentage of the total amount of money in bank that Tom should spend on food. Just now that percentage was half, which is 50%. Okay, now we need to let it be x. Just now, this is for just now the expression. Now we need to let percentage be x. Okay, then if the percentage is x, okay, let w be, or let w be the amount left. Let the amount be the amount left in the be the percent, no, let amount be the percentage of total amount of money left in bank account after each withdrawal. Okay, after each withdrawal, that means my w is just equals to 1 minus x, because if I withdraw 50%, my w, the total percentage of total amount of money left, will be 50%. If my x, the amount of the let percentage of maximum, okay, this x was my let maximum percentage of total amount of money spent on food be X. So if the percentage was 30%, that means I was left with 30% of the total amount. So I will try to use the previous part of the question and change my UN formula. So you see, if then what would be this? Okay, so my UN would change to equals to, if the X be the percentage. So how about this? I let 1 minus X is the amount left, percentage left from the previous month, right, plus 400. This would be my new expression. Okay, so I'm going to do this. I could do the same for okay, either one of these would be easier to make. So it could be or it could be written as Wn minus 1 plus 400. So we'll see, because we are still crediting $400 to the bank account. It's just that the percentage withdrawn from the previous total amount is percentage withdrawn from the total previous amount is the different. So this is the percentage of total amount left. So probably it's clearer if I, instead of W, I let left, since you left, so I just let it be L, so it's clearer, because W may seem like withdrawal. So instead of X, I let it be withdrawal. Okay, so this would be withdrawal now. Okay, the amount. Okay, so would this be easier to work with, or this easier to work with? I'm just choosing between the two. Okay, and I've tried working with this first, and then I will be able to get the same. So this is one term, it is easier to work with. So yep, so then I will let this UL, then what is this? Then my UN is equals to, let's say if I go back to use this to change, instead of starting all over again, I realized that my half was the amount remaining. Okay, half was the amount left, was half here was the amount of the percentage left from the previous. Okay, so I will use this as this. So I will put L to the power of what? So see, I'm going to use this part. That means L to the power of n multiplied by 250 plus 400 times 250 plus 400, 1 minus L to the power of n over 1 minus L. I believe that was the equation. So let's check. 1 minus L n over 1 minus L. Okay, L to the power of n times 250. Okay, so we have this expression, and I know that I want U12. That means I want U12 to be greater than equals to $850, so that I could have, so that means my U12 is L12 250 plus 400, 1 minus L12 over 1 minus L. I want to solve that such that it is greater or equals to $850. So 1 minus L, since L is a percentage, therefore it must be less than, L must be less than 1 or equals to 1. Okay, definitely less than 1, because you need to withdraw some money for food. So I let it be less than 1. Okay, in order to solve this inequality, I can maybe first thing I will do is to divide everything by 50 so that it is a smaller number. So when divided by 50, this becomes 5, and when divided by 50, this becomes 8, and 1 minus L to the power of 12 and 1 minus L greater or equals to 12 is a positive number, so when I divide, I do not have to change this sign over here. I don't have to change this sign over here. So then 5, 1, 5, 35, 17. So this would be the, and what could I do next? So I could also change it. I could also multiply 1 minus L on both sides, because 1 minus L is smaller than 1, so 1 minus L must be greater than 0. Okay, so this is greater than 0. When I multiply on all the terms, I do not need to change the inequality sign. So this one I will have 15, no, I will have 5L12 multiplied to 1 minus 5L12 multiplied to L becomes 5L13 plus 8, 1 minus L12. Okay, I will just multiply in straight away. So 8 multiplied by 1 is 8. 8 multiplied by minus L12 is minus 8L12. Greater or equals to 17 multiplied by 1 is 17, minus 17 multiplied by L is minus 17L. I'm just multiplying this term, this denominator, to all the terms. Okay, and that is about it. So this one I'll simplify. So 5L12, if I cancel away, so this would becomes 5 minus 8 would becomes minus 3. Okay, so I just erase this part, and then 17, 8 minus 17 would becomes minus 9, and this would be minus 17L. If I bring over to the other side, would be plus 17L. So plus 17L greater than 0. Okay, greater or equals to 0. Okay, then from here I will do what do I do? What I can do is to solve using a graphic calculator. Alright, and let's see. I'm keying into the graphic calculator now. And see what's the graph that I get. So what you do is you set the window. Okay, I'm using the TI-84 plus calculator. Okay, then for my window, since I expect the value of my L to be between 0 and 1, therefore my X min, I let it be 0, and X max, I let it be 1. And because the intersection point is going to be at y equals to 0, therefore I let the y minimum to be minus 1 and my y maximum to be equals to 1, so that I can see the intersection point. And then you could adjust other values as well, it's up to you. So when my y equals, I will let it be I will key in this expression for this expression here for my y1, and the y equals to 0 for my y2. Okay, and then what do I get when I graph it? When I graph it, I get a graph like this, where this is the x-axis, and a graph that is like pretty straight. Okay, from between from between 0 and from between minus 1 and 1, it looks like a pretty straight graph. Okay, and the cutting point. So I will just use the calculator to find the cutting point. For Texas, I'll press second and I'll press the button trace, which means calculate. Okay, when I calculate, and then I'll press 5, which is to find the intersection point, and then I will just press enter 3 times. Okay, so when I press enter 3 times, I get this value L, this point to be 0.5295734. That means since I want it to be, the part to be greater or equals to 0, that means I want this part of the curve, because this part of the curve is greater or equals to 0. That means I want my x values to be, in other words, my L value, because I'm using x to represent L in the calculator. So that means my L values would be greater than equals to 0.5295734. And because that means the percentage left is this, so the maximum percentage I should of withdrawal should be W should be lesser than or equals to 1 minus 0.5295734, and that means I'll take 1 minus 0.5295734, and that is about approximately like 0.5470466. Okay, this is the maximum. That means the maximum percentage. I could write it as 0.47 or 47%. Okay, could write it as, so the answer to this question would be about 47%. Okay, let me know if you have any feedback for this video.